Ignition sequence start.
Good morning. You've got a view of the International Space Station Flight Control Room at NASA's Johnson Space Center. The flight controllers in this room are keeping track of the systems on the space station and helping out the Expedition 62 crew members as they work through their agenda of science and maintenance tasks. Now, we've made a few changes around here about the way we're doing things on the ground during the novel coronavirus, but that hasn't kept the crew on orbit from doing their work, preparing for the upcoming departure of a cargo ship and the arrival of new crewmates.
Welcome to Space to Ground. I'm Sandra Jones. While the world continues to grapple with the effects of the coronavirus pandemic, we are doing our part to help flatten the curve by shooting this week's episode from home. Meanwhile, 250 miles above us on board the International Space Station, crew members were busy preparing a vehicle for its upcoming departure. In preparation for the SpaceX CRS-20 Dragon cargo vehicle departure, NASA astronauts Jessica Meir and Andrew Morgan have been loading the vehicle with experiments and station gear, such as spacecraft components to be analyzed by scientists and engineers upon the vehicle's return to Earth. CRS-20 is scheduled to be released from the space station on Monday, April 6th. The vehicle will splash down in the Pacific Ocean just a few hours after its departure from the space station. In preparation for the release of CRS-20, the first external commercial research platform, called Bartolomeo, was removed from Dragon's trunk. This week it was robotically installed onto the Columbus Laboratory module of the International Space Station. Bartolomeo will provide power and data transmission for up to 12 payloads mounted outside the orbiting laboratory. 3 more humans will soon arrive to station. NASA astronaut Chris Cassidy and Roscosmos cosmonauts Anatoly Ivanishin and Ivan Wagner are scheduled to launch April 9th aboard the Soyuz MS-16 spacecraft from Launch Site 31 at Russia's Baikonur Cosmodrome in Kazakhstan. The Expedition 63 crew members have been completing final training and preparations ahead of their upcoming launch. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
As most of America gets acquainted with working from home, sometimes in cramped quarters, a number of International Space Station crew members have been sharing their experience of doing that same thing from space. Recently, astronaut Anne McClain pulled out her smartphone to talk about the 5 expeditionary crew skills that space station astronauts try to employ to make their team on orbit a success. These skills may work for you on Earth, too. Take a look.
Hey everyone, Anne McClain here. I'm a NASA astronaut and I lived on the International Space Station for about 6.5 months last year. And I know a lot of people find themselves in confinement right now or living in quarantine under conditions that maybe are not the most favorable. So while we recognize that the situation right now in the world is very different than what we have up in space, I do think that there are some parallels, some lessons that we learned over the last 20 years living on space station that maybe can apply to your scenario. And I think the big thing that I realized was that it's a big mental adjustment when you're living and working in space. People think of space exploration as solely a technical feat, but really there's a huge non-technical aspect that is critical in our success. And that's pretty simply how well we can get along with others. If you have a crew that goes to space and a month into it are not speaking to each other, that's just not going to be an effective team. So about one of the astronauts that flew a few years before me, Peggy Whitson, she worked with Dr. Al Holland, one of the psychologists at NASA, and they developed what we call now expeditionary crew skills. And these are basically 5 main skills that they identified were important and critical to these successful teams. And those 5 skills are communication, leadership and followership, self-care, team care, and group living. So the first one, communication. That's basically how to express oneself so that you're clearly understood. It's also how to be an active listener and ask questions so that you know that you understand what's being said to you. And it's actually amazing how many problems are generated just because of miscommunication. And so we talk about this aspect and some of the behaviors that contribute to good communication. So things like active listening and asking questions like I just said, using concise terminology, maybe waiting to speak until your emotions have subsided and you can speak more factually instead of emotionally. The next skill is leadership and followership. And that's basically how the team hierarchy adapts to a changing situation. And, for me, I kind of talk about leadership and subordinate leadership, because really everybody is a leader no matter what level that you're at. Even your kids can be leaders. And so, the leader is the one that officially sets the goals of the team and perhaps leads by example, strengthens relationships, and kind of has that responsibility. And the follower, or the subordinate leader, sets their own goals and their behaviors in order to support the vision of the leader. And so you can apply those roles kind of in whatever group that you're in. Maybe you don't have an appointed leader, but maybe you have somebody that's kind of more of a natural leader. And, some of the skills, some of the behaviors for this leadership followership is that you can effectively occupy both leader and follower roles. So maybe someone is, a leader in one aspect, in one task that you're doing, and then very later on in that day, somebody else takes the leadership role. And so, the ability to kind of suppress that ego and say, okay, I'm going to lead from the front on this one, and on this one, I'm going to defer to somebody that may be the expert in that. The next skill that is important for expeditionary crew skills is self-care. And this is so important, because if you don't take care of yourself, if you're not healthy, then you can't perform for the team. You can't be a good team member. And further, you may actually have to pull skills from the rest of your team, or pull resources from the rest of your team for them to take care of you. So knowing when you need to stop and take care of yourself is very important. And so this is how healthy you are on a psychological and physical level. And you really have to pay attention to that. Sometimes when we get in these awkward situations, our first instincts aren't the right instincts. When we have stress in our normal lives, maybe we can skip the gym one day, or maybe we go out and, we just decide to watch TV and ignore life for a little bit. Well, we're all going to be in this current situation and in confinement and a little bit too long to just kind of sit and watch TV or consume social media. So we're going to have to be active about how we self-care. And so this is, trying to manage your own emotions. Some of the behaviors that can help you with this is try to be calm in the face of stress. Recognize that stress is when expectations don't meet reality. And we can't change the current reality. And so it's probably a good idea that we try to manage some of our expectations. You want to maintain your social relationships. Don't cut yourself off. And if you start to get into a negative thought pattern, then, recognize that and try to get out of that. And sometimes it's just taking care of yourself physically. Take the time to go to the gym, eat right, take time away from the group for some solitude if you need to, read a book. And the next aspect is team care. And team care is how healthy the team is on a physical, psychological level. And this can be influenced a lot by external and internal stressors. So some of the good behaviors to help with team care is to demonstrate patience with others. We're all human. We're all going through this. We all have emotions. Whether we're on the space station or whether we're on the Earth, we have good days, we have bad days. We feel stress, we feel frustration, sometimes we feel anger. And recognizing that we want to be able to forgive ourselves when we feel those, but we also want to forgive those around us. And so let's just give each other a little bit of grace. You want to monitor your team for signs of fatigue and stress and catch it early. Maybe take some of their tasks or and help them out with it. Say, hey, I'm going to go do this. Why don't you go read your book? Why don't you go on a run? Why don't you go do something? Volunteering for the unpleasant tasks. There are certain tasks when we're group living that nobody wants to do, and sometimes it really just helps the psyche of the whole group if you can volunteer for those. And that's the next one is group living. A lot of us find ourselves in a group living scenario. And that's basically how well we cooperate with each other in order to integrate into the team in order to achieve a shared goal. And hopefully, based on what we talked about a minute ago, we've set goals. Even for this quarantine period, we can set goals that the team is striving for, that each individual is striving for, and we can help each other reach those goals. Some other behaviors that can help with group living is to act cooperatively instead of competitively, make use of available team resources, Respect other team members' real roles and responsibilities and what they're faced with. What are their stressors? Actively work to ensure a positive team attitude. Sometimes if you're thinking negatively in your mind, then be very deliberate that what comes out of your mouth is positive, and that can actually, pull ourselves out of a negativity.
In a few minutes, more from Anne McLean, sharing some insights from her experience that may help you be successful as your team figures out how to work together from less than ideal locations. Drew Morgan and Jessica Meir, two of the Expedition 62 crew members who are now 2 weeks away from returning to Earth, are astronaut classmates of Anne McLean's, each also finishing their first spaceflight. While Meir spent years being trained for this mission, she already had a bachelor's degree in biology, a master's in space science, and a doctorate in marine biology. Yet little of all that formal education much mattered when she agreed to sit down with us before she left Houston for a barrage of, non-technical questions. Take a look.
The clock has started. Surrender.
What's your favorite color?
Green.
Favorite book?
Anna Karenina or Galapagos by Kurt Vonnegut.
Favorite song?
Probably anything by The National.
Are you a morning person or a night person?
Definitely not a morning person.
What's one thing you're afraid of?
My plant's dying while I'm on the space station.
Who is the person who makes you laugh the most?
My best friend from college, Jacqueline.
What is something you do outside of work to have fun?
Spend time in the outdoors and nature, hiking, skiing.
What's your favorite animal?
Probably an auk, a seabird like a murre.
If you could have one superpower, what would it be?
Definitely to fly.
The most valuable high school or college class that you ever took?
My introductory biology class at Brown.
Most important advice you would give to your younger self?
Appreciate and enjoy the moment.
Who inspires you?
My mentor from grad school, Jerry Koyman.
What's a goal you plan on achieving this year?
To fulfill my future plans from my high school yearbook to go for a spacewalk.
If you could spend one day on Mars, what would you do there for fun?
Explore. Maybe some kind of sand dune surfing.
The astronauts and cosmonauts on the International Space Station serve as laboratory assistants for scientists who are studying a wide range of scientific concepts, and that includes some concepts that we'll have to master in order to return American astronauts to the moon by 2024 as part of the Artemis program. For example, it'll be critical to learn how to interact with regolith, the fine dust particles that cover the moon's surface. And we're using the Hermes facility to study how regolith particles move in microgravity over a long period of time.
If you look at asteroids or if you look at the moon, you'll see this layer of regolith covering the surface. So it's this fine particles, fine dust that covers the entire surface. So what's happening is the solar system is very dynamic, and we have asteroids and meteoroids moving around and impacting different bodies. So the surface is getting bombarded all the time. So you have this fine layer of fragments on the surface. So why would we want to study it, right? And why would we want to study it on the space station? There's a lot of interest in one day sending astronauts to asteroids, for instance, and we have already sent a lot of robotic missions to asteroids and plan to send more. And so every time we visit these asteroids, we learn more and more. And there's very diverse bodies of asteroids. Every asteroid seems to be different. And so we would need to understand how to interact with the asteroid surface. So if you're going to anchor to the surface of the asteroid, for instance, you need to understand how to interact with the regolith. So asteroids are pretty small bodies, and so they have actually microgravity levels of gravity. And so this is actually what you find on the space station as well. There's 4 experiments, and each one is a tube. So it's a clear polycarbonate tube about the size of a Pringles can. And so inside this tube, we have the asteroid simulants. And so this is what we're actually studying. And so the main piece of data that we're getting is the movement of these particles. So we have a camera looking at each of these tubes. Over the course of about a year, that cassette 1 will be up there, we'll get this basically time-lapse imagery of the particles moving. And so we're looking at the long-term effects of microgravity and what's happening to the movement of the particles. Also, something that we have on asteroids is vacuum, right? So we want to expose our experiments to the vacuum of space. So we actually have our facility hooked up essentially to a port to space. We did cassette 1, but the idea is that Hermes will be open to other investigators. So cassette 2, cassette 3, cassette 7, these will be other researchers that will apply to use Hermes to do research on asteroid regolith and granular material investigations. And We think that ISS is a wonderful place to study asteroid regolith, to study lunar regolith, regolith in general. So we're excited about the opportunities that Hermes will bring for researchers in the future.
A few minutes ago, Sandra mentioned Bartolomeo, the first external commercial research platform on the International Space Station, just installed on the outside of the Columbus module. The exterior of the International Space Station is a great place for science. Over on the Kibo Laboratories exposed facility, there is a package pointing a laser light down to tree canopies on the planet to study Earth's ecosystem, as scientists want to learn more about how it's changing.
Shining laser light on Earth's forests. Presented by Science at NASA. The International Space Station, or ISS, is sporting a new light fixture. The Global Ecosystem Dynamics Investigation, or GEDI, will beam down laser light on Earth from the orbiting laboratory to reveal more about our environment and how it is changing. NASA's GEDI sends laser pulses into tree canopies and precisely measures the light reflected back. The timing and intensity of light that bounces back to GEDI's telescope will reveal the height and density of trees and vegetation, and the vertical arrangement of the leaves and branches within the overall canopy. Dr. Ralph Dabaya, GEDI Principal Investigator at the University of Maryland, says, "This instrument will map forests in high resolution and 3 dimensions, revolutionizing the way researchers monitor them. Forested areas are an important part of our planet. Not only do forests provide a habitat for many species and a source of raw materials for human use, such as paper and lumber, they also play a key role in the Earth's carbon cycle. Deforestation and forest degradation, in addition to other types of forest disturbances, such as fires and insect outbreaks, lead to increases in atmospheric carbon dioxide. Forest regrowth sucks that carbon back down into trees and soils. Knowing how forests grow and change over time can allow us to better understand the contribution that forests make to Earth's carbon cycle and help people better manage this important resource. GEDI is the first spaceborne instrument designed specifically to perform sustained mapping of the spatial distribution of the carbon content of forests." Dabaya notes, "One of the most poorly quantified components of the carbon cycle is the net balance between forest disturbance and regrowth. GEDI will help scientists fill in this missing piece by revealing the vertical structure of the forest, information we really can't get with sufficient accuracy any other way. GEDI will provide scientists with insights into the amount of carbon stored in forests. When combined with current and historical records of changes captured by Earth-orbiting satellites, such as Landsat, this information will enhance the ability of researchers to identify changes happening across our planet. Researchers also will incorporate GEDI's observations, along with those of the EcoStress instrument on the station, with data from other current and future Earth-observing sensors. These data will address important questions about relationships between forest structure, function, composition, and changes in carbon content. Combining all of these data will allow researchers to gain an unprecedented understanding of ecosystem dynamics and the role plants and trees play in Earth's global carbon cycle. These new insights could be used in turn to improve models for forecasting future ecosystem changes, atmospheric carbon dioxide concentrations, and climate. GEDI was launched to the station aboard SpaceX CRS-16 on December 5, 2018. For more about how NASA uses the power of light to understand our world and beyond, visit science.nasa.gov.
The astronauts on the International Space Station spend a good chunk of their time as lab assistants on experiments in a whole range of scientific disciplines. But they also devote time to sharing the experience of spaceflight with people on the ground, particularly when they talk with students and their teachers about science, technology, engineering, and math. In this installment of the STEMonstrations video series, Astronaut and former classroom teacher Joe Acaba gets into the difference between kinetic energy and potential energy and demonstrates how one can become the other.
Welcome to the International Space Station. I'm astronaut Joe Acaba. Today, we're going to talk about potential and kinetic energy. Let's get started. Kinetic energy is the energy an object has because of its motion. An object can store energy based on its position. This is called potential energy. On Earth, imagine dropping an object from a raised position. As an object's altitude above the Earth's surface increases, its gravitational potential energy also increases. The potential energy stored due to its position is now being converted to kinetic energy. We also observe this with elastic potential energy.
Okay, new term. Elastic potential energy occurs when objects are compressed and stretched, or generally deformed in any manner, creating potential energy. Think of this bungee or a spring. Okay, Joe, what's next?
We pull back on the band and create potential energy. When we release the potential energy, it is converted to kinetic energy. Here on the International Space Station, we are still under the influence of gravity, primarily due to our position with the Earth. So when I have this ball on this ramp, normally back on Earth, I release the ball and it rolls down the ramp due to a change in its potential energy that's being transferred to kinetic energy. But as you can see, it doesn't happen here. So it doesn't mean we don't have potential energy. It just means we're not converting it at this time to kinetic energy. And why is that? Gravity is pulling us down, but we're moving super fast. And so what it is we're bending around the Earth in this perpetual falling motion. Thanks for joining me on board the International Space Station. We're sending it back to Earth so you can try your own experiment. See you next time.
Earlier today, we spent a few minutes with astronaut Anne McClain talking about the skills astronauts have developed to work well together as a team during a mission to the International Space Station. The Space Station veteran says it takes a mental adjustment to work successfully in a new location orbiting the Earth, just as it may if you're working from a room in your own house during our current period of social distancing.
I think really what I wanted to emphasize to everybody is that it's a mental adjustment. It's a mental adjustment when we live in space, and it's a mental adjustment to be living in whatever level of quarantine or self-isolation or social distancing that we're living in right now. And the big thing is it's okay to not be okay. But it's what you choose to do about that that's important. You know, make sure that you're not taking your stress and putting it on everybody else by lashing out or sharing what's stressing you. Maybe just give yourself a little grace and recognize that you're stressed, and then really deliberately try to act for the better of the group. And that's your group that you happen to maybe be living with, and that's also our greater community. All of us right now are trying to behave in a way to help our greater community. And I think more than any time right now on Earth, and what we definitely saw from space, is that we're all in this together. And we need to be intentional. We can be successful in confinement if we're intentional about our actions, if we take care of our teams, and we can do practical things to help our teams. One of the practical things that we can do is to set goals. And you know, it might sound weird to set goals as a small group, but each of us individually and as a group, we work better when we're going toward goals. So if we just mentally adjust to this new normal and say, okay, well, you know what, in the next 3 weeks, I didn't anticipate to want to do this, but this is what I want to do. And we share that with a group. And then as a group, we set our goals. And then we can hold each other accountable during this time. Another way is to bring the outside in. Up on space station, holidays were one of my favorite things. And, certainly holidays were not the same as what we had on the ground, but we made it work. We found decorations, we set music, we took the time to bring the outside world into our space station. And so maybe be really creative about how you can bring the outside in. Maybe somebody in your group has a favorite restaurant or a favorite activity that they just can't do. Well, how can you recreate that for them in a confined environment? I want everybody to really consider your effect on the group. When you're able to, like I said, bring the outside in for somebody else, you're really helping the group. You're making it so much better for everybody else. And likewise, if we get stressed and we don't think about it and we don't give ourselves grace and we lash out, we can really affect the group morale. And I want to leave you with something that Christina Koch said recently. Christina Koch, for those that don't know, she just came back from spending 328 days on the space station, and is also lucky to have her as a friend of mine. And something she said really stuck with me. And she said that to get her through the days up on space station, she would think about the things that someday she would miss. Yes, she missed Earth when she was up in space, but she knew that at some point she would be looking back at that time and wishing that she could have certain things back. So she tried to identify what those are and really enjoy those. And so, we're often so busy in our lives, and whether we chose it or not, we've all had to pause a little bit right now. But maybe there are aspects of this that we're going to miss when it's over, just from a family standpoint. Maybe it's spending extra time with our kids, or getting to participate in our kids' education, or spending more time with loved ones, or finally cleaning out the garage, whatever it is. So whatever that is, I hope that everybody can stay ahead of the mental game, be very intentional on what you think about, set your goals, and just like we do up on space station, we can all be successful during this period of time. Good luck.
If you'd like to get another look at any of the stories we featured today, and who could blame you, check us out on YouTube and Facebook. The addresses are appearing there on the blue box on your NASA TV screen. While you're there, be sure to look around, because there's lots of other cool stuff you can find about NASA and America's human spaceflight program. If you're going to be out on the internet anyway, you should check out Houston We Have a Podcast. That's where we talk to folks about their work in all aspects of space exploration. We post new episodes every Friday, and today, Gary Jordan talks with NASA astronaut Chris Cassidy, who is on target to launch to the International Space Station next week on his second long-duration flight. Go to nasa.gov/podcasts for today's episode. It's where you'll also find all of our previous episodes and the full library of all the different NASA podcasts, all of which you can also listen to on Apple Podcasts, Google Podcasts, and SoundCloud.